This is Vidyasagar Krishnamurthy, registration ID PR16IT1006. This is a recording of my first experiment with network management, and the aim of this experiment is to familiarize yourself with the most basic commands for network management. So, of which, let's begin. So the first command is ipconfig, which is practically used to display the DHCP configurations that are specific to your system. So it's very simple. All you have to do is just type ipconfig. You enter, it'll throw out all the adapters, and the ones that are connected will have an IP address and all those things. So if you see, in my case, my wireless is connected. So if you could see here, you can see just the details of the wireless LAN adapter, and the other ones will have status like media disconnected or nothing of that sorts. So the next next command will be ping command. So the ping command is basically to check if the target machine is up and responding or not. So it's pretty simple. All you have to do is ping and then your target IP. So in this case, the 10.2 is not connected, so it will throw out a request timeout, which means I will be getting 100% packet loss. So in this case, if you could see the metrics over here, my machine has sent out 2 packets and it received 1. So if the target machine is up and running, and if the ICMP request is active in that particular target machine, it will also send you response packets. So if it sends you response packets, it will be sent equal to 2 and receive is equal to 2, and there won't be any packet loss. So that's about it. And the next one will be trace route command. The trace RT command is basically to trace the route of the packet that is being sent to the destination. So it will throw out all the the route IP of the routers that are passed and all those things. So it's pretty simple. It's pretty straightforward command. So if you could enter trace RT, it will show all the parameters or that is to be passed. So if you could see over here the -D and -J and W and stuff. So -D is to so that your command doesn't resolve the addresses to the host names, or else what it does is it will take up the address, and right next to it it will enter the host name corresponding to that address. Say if www.google.com is associated to an IP of 10.10.10.1, so it will have a 10.10.10.1 and www.google.com. So that will take considerable amount of time. So to avoid that overhead, you can add -D option, and -H is the maximum number of hops. This is practically the hop limit. You specify, you enter -H and then you enter the hop limit. So what it does, it doesn't allow the trace route to exceed that particular hop. So if it's 30, then it will go for 30 hops and it won't proceed further. It'll just drop the packet and then it will produce the results. And -6 is for to force use IPv6, and -4 is to force use IPv4, and -S is to to explicitly specify a source address. So you can give a -S and then you can give a source address and space a destination address, which means the packet will be sent from the source address to the destination address. So let's try it out. So in my case, I'm going to type -D www.karunya.edu. So by default it just takes maximum of 30 hops. So this will be my next gateway, next address, and this is the IP address of the destination. So it just goes off, and I think trace route, it's disabled, I guess, so it's taking a lot of time, so it's pretty much going to throw out a timeout in a couple of minutes. So let me quit. Control C, and there we go. So next one is NS lookup. So the NS lookup is basically used for querying the DNS server. So there are 7 records there are 7 type of records in a DNS record, which are the IP and the mail exchanger, the canonical name, and the name server, the state of authority of the DNS, and the type of OS and services that are being run in the particular DNS server. So you can check out the parameters over here. So this is the command, and once you enter nslookup, it will take you to the nslookup terminal, which is a separate thing. So what you can do is to set the type of record, you can type set type is equal to A means just the IP address, and you can enter, and then you can enter the target. And so yes, so this is the IP address of the DNS or server for karunya.edu, and there is another option called any. So if you type any, it will throw out result of all. Okay, I'm recognized command. Okay, and it will throw out all the data pertaining to all the records. So now you give if you could see, you'll have an unauthoritative answer, which means it's querying from its local cache, which means I have queried it a number of times. So you can see the name server as urim.karunya.edu, which is the canonical name, and the INET address will be this. And so for security reasons, what they do is they disable DNS querying for most nowadays for most of the sites. So these are only just the most basic banners that you can see will be displayed. So you can just quit it, Control C. So the next thing is netstat. So netstat we use to check out the network and the TCP/IP configurations within your local machine. So it's a pretty straightforward command. So you just have to give netstat, and then it will show all the TCP/IP connections, the TCP connections, or any port connections that are associated with it. And so yeah, there are a few things about a few parameters which are very useful for netstat. Let me get it for you. So these are the parameters for netstat -a, or you can use either of these parameters. So -a is used to display the active display connections and the ports that are listening, and -r is for the kernel routing table of your local machine, and -n will be to display the addresses and ports in the numerical form and not in the resolved form, and O will be it will display the process owning that particular connection. So if a process called say Skype, it's opened a connection to the network, and the process ID, say it's 14121A, and it will have another parameter as 14121A is owning this particular connection to this particular service. And F will be the fully qualified domain names for foreign addresses, and that's pretty much straightforward. And E will be the Ethernet statistics, and T is the current connection offload state. It's pretty sure. I'll show it out to you. Estimate. So yeah, so netstat -a will throw out all the connections. It just keeps going. It's TCP, UDP, or whatever. And so it takes a lot of time. See, if you could see, these are the connections, these are the ports that are established to which connection, and these are the status of it. Established means both the client and the network both the client and the server, the destination has established a connection. Close wait means the client has initiated a close request with the thing, and it's requesting a response from the destination. And time wait is similar to that thing. We have initialized a request, and the destination is still yet to respond to it. And yeah, that's about it. And so let me show you -o. So let's start -o and -o. So if you could see this is a foreign address. This is the process ID, and associated with each of the established connections and its status and to which port it is connected to. And there is another option called -b. It's lately introduced for Windows operating system. This is practically used to check if there are any malwares that are connected to anything. So Netstat, as a whole, you can also use it for checking for malware connections. If you could see, we'll throw out a detailed thing over there with which particular application is using which particular service, and it's connected to which particular destination. So if you could see here, OneDrive is using this particular port and it's connected to this particular destination, and the connection is established, so on and so forth. See, Chrome.exe is using this particular port and it's connected to this particular IP, this particular destination. So, and in a way, you can also check if any unauthorized programs are running by analyzing the particular executable that's being run, displayed over here. So that's it. And then let's go for path ping. Path ping is similar to traceroute, but what we can do, what path ping does is it sends repeated ICMP echo requests to a particular router along the entire route to the destination. So it's also, what it does is it also maps the route, but in addition to it, it is also used for analyzing packet loss. So that's about it. See, these are the parameters that are associated with path ping. So -g will be the host list, -h will be the maximum hops for each target, similar to traceroute. -i will be the source address, similar to it, and n, again, do not resolve the host name, and p is the period of milliseconds that you can wait between each pings to each router, between each request. So it's practically like a timeout. If I'm not requesting any, if I'm not receiving any responses after that, it practically quits and then it moves out to the next router. And q will be the number of queries. So per hop, you can set the number of queries, say for example 4 or 5 or something, whatever queries. So, and w is the timeout for each reply. And -4, -6, just like traceroute, it's for force using IPv4 and IPv6. So let me check. I think I'm going to receive the same response as traceroute. Let me check. Yep. So pretty much that's how it works. So what it does is at point 0, which is my machine, the next one will be the next router that I'm using and it has responded for the pings, and so it comes out over here, and we don't essentially have a packet loss, but we don't have it. This particular router doesn't have the permissions for us to execute these commands and see, because once we do it, it can be, again, it's for security purposes. It's another way of banner grabbing and stuff. So yeah, and we've got path ping, and let's go for ARP. ARP is nothing but address resolution protocol. It's nothing but it's a table of it's a table which has got the IP and the corresponding MAC addresses associated with the particular IP addresses, so that it's easy for us to route it across. So every system, every switch has got an ARP table. Every machine has got an ARP table, and yeah. So if you could see it, this is the ARP table of my machine. So these are the routers or switches that are associated with my connection. So what it does is it doesn't have to refresh everything. So that it's pretty easy for it to route the packet through all these devices, and it's faster. So that's pretty much it. And you have other parameters in ARP as well. So for example, -d is used to delete a particular thing, so the parameter will be -d space a mac. So if you want to delete the entire table, you can combine it with -a. So if you give ARP -d DA, the entire routing table will be deleted. And yes, -s is to add an entry manually, and display -v is to display it in verbose mode. Since verbose mode is nothing but an interactive mode. So that's about it. And there is this command called route. So the route command is used to display the local IP tables. It helps you to manipulate it and check for other things and stuff. So this is the command. These are the parameters that are associated with route. So -f is to clear the routing table and all the gateway entries and stuff, and then -p is to add something manually. It's to make it persistent. It's to save. It's to add manually and save it. -4 is for force using IPv4. -6 is for force using IPv6. And these are the main 4 commands. If you could see over here. So print is nothing but it prints the route. Add is to add a route, and delete is to delete a route, and change is to modify an existing route. That's pretty straightforward. So if you could just check this out, space print. So this is how it is. These are the active routing routes that you've got. So these are your routing tables. These are your IP tables, and your interface list. Interface list is nothing but the available, interface devices that are associated with your computer. So that's how it will be. These are IPv4 routing tables, and these are IPv6 routing tables. So that's pretty much it. Yeah, that's about it. And so sometimes you can also get it based on a particular destination. So wherein this will be the command for it. So practically route space whatever you want to add, print, add, change, delete. So we'll go for print, and then the destination will be a destination IP or a host name, and the mask is the mask associated with the destination IP or the host name, and the gateway is your immediate next hop, as in your gateway will be your ISP's next hop or your router's IP or things like that, which you can get it from traceroute or pathway. And metric is to specify, it's practically an integer. It's like a score. It's based on the kind of routing protocol that you're using. So it's a predefined score. And then the interface, whatever it is, if it's TCP or IP or whatever. So that's about it. That's pretty much it. And then when you specify all these things and when you give enter, it spits out the routing table accordingly. Pretty straightforward commands. These are pretty simple to execute as well. And get MAC is a command to get your network interface MAC addresses, so physical addresses. So these are the physical addresses that are associated with your device. And ipconfig all, what it does is it just spits out the parameters and all those things specific to each and every adapter. See, for example, for wireless LAN, it's got all the data necessary for that are pertaining to a DHCP connection. And LAN, it's not connected because it doesn't have all the data because it's not connected. So you'll have the basic physical data of those and not the logical data. And then there's telnet. Telnet is nothing but it's to enable you to take control of a remote machine. So telnet space 192. So let's see, let me just try ftp.caronia.edu. So it basically helps you to take control of a remote machine. In this case I won't be able to, but I'm just showing you how it is done. So once it establishes connection over here, it asks you for a username and password. So when you are authorized to enter, and then you will be able to manipulate the other machine. So in this case, I don't have the permission to do a telnet. So yeah, it's obviously lost. And then the last command is FTP. FTP is nothing but file transfer protocol. It's pretty straightforward, similar to telnet, and it works exactly like telnet, except that it will give you the directories that are accessible to your ID. So it's pretty much the same command. So ftp.karunya.edu. So it asks for user ID. I'll just give my ID. I won't have a permission, but just for the sake of explanation, it will ask for a password. So the same thing, and it will verify the password, and it will throw out an authentication failure exception. But if it is succeeded, what it does, you'll be entering into the FTP mode, FTP terminal, wherein you will be able to list the directories and change what it is, change the permissions, and all those file operations that you can do. And so yeah, that's about it regarding these things. So thanks for watching.